Welcome back to another video. My name is Michael. I'm the founder of Buffalo Performance and Analysis, where we combine sports science, strength and conditioning, and sports performance to give coaches the tools necessary to build the next level of elite athletes. In this video, we are doing another RScript video looking at my code utilizing RStudio. This is going to be a continuation based off of our first video, so if you have not seen that one already, I highly recommend that you check it out. Like in the first video, we're utilizing tidyverse and dplyr as our two main packages, so we've gone ahead and installed those and loaded them to our library. Now we've gone ahead and added an additional data frame, loaded it from a CSV format, so when we call this script, it's going to show us another data frame, and we see that there are 267,000 entries versus when we looked at the first video, we only used the injury record data frame, and that only has 105. So there's going to be some data cleaning that needs to take place before we can utilize what occurs in the playlist CSV. But we see that we have a player key, we also have a game ID, as well as a play key, as well as the roster position. These are the main ones that we're going to be utilizing, but it also goes into where the stadium was, whether it was indoor or outdoor. Again, it has the field type, whether it's natural, grass, or synthetic. It also gives us valuable data such as the temperature, the weather, and then additionally the play type. So you can even break it down and see where the injuries occur, whether more injuries occur on passes or rushes. So once we've called in the new data frame, we need to clean that data as well as combine the data that we need from the playlist CSV with the injury record CSV. What I want to be able to do is to determine how many injuries occur per position. So from that, what we're going to do is we're going to create a new data frame, and we're going to call it injury_main. The first thing that we're going to do is we are going to merge the two data frames. So we're going to merge injury record data frame with playlist data frame, and we're going to merge it by the player key so that we know that the player key data is core-aligned with each other. Once we've done that, it's given us a massive data frame with all of the columns. So what we need to do is filter out the columns that we don't need, so we're left with only the columns that we do need. So again, we're going to call on data frame injury_main, and we're going to use a subset of that, and we're only going to select and use the concatenate function the player key, the body part, the surface, as well as the roster position columns. So those are going to be the only 4 columns that we're going to see. But then when we do that, if we were to run it just like that, we're going to have duplicate values in there. So what we need to do is we need to remember that there's only 105 unique injuries. So we need to use the distinct function to filter out any duplicate factors. When we run these lines of code, we're going to see something a little bit interesting. We're going to see that there are only 103 entries as opposed to the injury record, there are 105 entries. That is because there are 2 athletes that got injured twice during the course of the season. When we utilized the distinct function, it removed those 2 player keys and only utilized one of them. So it removed 2 of them. 105 minus 2 is 103. Now that we have a new data frame with the player key, the body part, the surface, and the roster position, we're able to utilize ggplot to graph some of these functions. In the first graph that we're going to look at the surface and how it relates to the roster position, utilizing facet wrap by position to see each position, the difference between the different injuries and playing surfaces. So when we run these lines of code, it returns a graph. And if we zoom in, we're able to see the differences in the injuries. This graph gives us a lot of information, and it allows us to ask more and more questions. One of which can be looking at cornerbacks, for example. We see there are about 2 injuries that occur on natural grass, while there are about 11 that occur on synthetic. Is there a statistical significance to cornerbacks getting injured on synthetic grass versus natural grass? These are questions that using ggplot we can start to ask and dive deeper into. The next graph that we're going to look at does not utilize facet wrap. The next graph that we're going to look at is also using ggplot, but we're not going to use facet wrap this time. We're going to create a stacked bar chart by roster position to see a comparison across all the roster positions. So when we run these lines of code, it returns a new graph. And again, we'll zoom in on this one. And we're able to see by position the number of injuries that each position has. From this graph, we're able to see that linebackers and wide receivers are the two most injured athletes. After that, safeties and cornerbacks are the following two most injured athletes. This is going to give feedback to the sports science staff, the sports analysis staff, as well as the coaching staff as to whether any adjustments need to be made to the training plan. Utilizing these simple tools using R and RStudio allows us the opportunity to dive into the data to a deeper level to understand what is occurring when an athlete gets injured. Like in my first RScript video, this is just an opportunity for me to post what I've learned so far utilizing R and RStudio, as well as a reference point for me to look back on in future years to see where I've grown.